Well, thank you for taking the time to watch the Oscar 2 installation video. We'll be covering what the Oscar 2 is, how we install it, and then how we follow the quality control procedures for the startup after it's been installed. And then we'll also talk about the certification process for getting an individual's name on our list of certified installers. This is a real brief overview of what an Oscar 2 system looks like. Very compact, small, couple of tanks, drain field. The Oscar is an acronym that stands for a sand on-site sand coil area recharge. Here we have a photograph of a Oscar that's been installed, and we're just waiting for the final cover sand to complete it. The Oscar 2 is a proprietary technology that meets treatment level C, and it also acts as a final disposal component. We are able to read a higher treatment level and have the minimum soil depth of 12 inches when we add a different treatment vessel that has a higher treatment level. And we'll get into that in a little more detail toward the end of the presentation. The Oscar 2 is comprised of four main components. There are Oscar coils, which come in two different versions. We have a 50-gallon a day unit as well as a 100-gallon a day unit. The OS50s are a 5-foot coil. The OS100s are a 7-foot diameter coil. We also incorporate C33 as a treatment media, minimum of 6 inches of sand depth under the coil. We incorporate a reverse flush headworks that help keeps the tubing clean and flowing. And then we have two tanks, a treatment vessel and a pump chamber. The OS50 coil depicted here is a 25 length of bioline with emitters at 6-inch spacing. So we have a total of 50 emitters in this coil. The white PVC pipe is a bracket that just holds the tubing in its shape. The green is just a background for illustration purposes. When the Oscar is installed, we will prepare the basal area. We'll put a layer of 6 inches of C33 sand down. The coil, which needs to be level, will be placed on top of the sand, and then we'll backfill or cover the coil with another 6-inch layer of C33 sand. After about a year or two, or one or two growing seasons, a grass lawn will grow over the top of the Oscar, forming a nice firm basis. This ground is, or the sand media is firm enough where they can mow this lawn with a riding lawnmower. To install the Oscar drain field is four basic steps. The first step is we want to stake out the basal area. If it's on a contour, we'll want to stake 3 or 4 stakes along the contour on the upper edge to determine that edge. But usually it's as simple as a rectangle with 4 stakes total. Once we've staked it out, we're going to remove excess organic material from the basal area. This does not mean removing the sod. It does mean mowing either whether it's a pasture or a lawn. If we've got very, very tall grass or weeds, we'll need to mow that off down to the sod layer. If we're in a forested area, we do want to take off the leaf mat off the ground down to the mineral soil. At that point, we're going to go and do the basal prep. And that's just as simple as taking the excavator bucket, placing the teeth about 2 inches into the soil, and doing a one-time pass. So we create little furrows within the ground. Whatever sod comes out of the ground comes out. Whatever stays, stays. And so at this point, then we'll go ahead and apply the sand to that surface. Sometimes the ground can be really dry, especially in the summertime, and it appears as if all we're doing is just kind of mix it up or pulverizing the soil. But regardless, we're always going to be creating, even though we've got loose stuff on top, we're going to be creating a structure within the soil that precludes water from being able to move sideways through the soil or down the slope of the site. The liquid will percolate down through the sand, hit the soil layer, and if we're on a slope, in order to move down slope, it would have to go over these little furrows or humps, and slowing the water flow down and allowing the soil maximum amount of opportunity to absorb the effluent. Once we've created the furrows, we're going to apply the sand. We'll spread that sand out to our minimum depth, again of 6 inches. The area that the coils will go in must be level, so if we're on a sloping site, we're just going to have about a 6-foot to maybe 8-foot wide path, depending on whether we're on using the 5-foot or the 7-foot coils, where we want to maintain the level pad for the coils. Once the coils are placed, we will connect them. The kit that we ship out will incorporate or include PVC fittings with the adapters, the solid tubing for making the connections between the drip tubing and the manifolds, as well as the couplings to make those transitions. It is important that we have a minimum of 6-inch spacing between the coils. We can be larger if need be. The simplest way to do the installation, once the coils are laid out, we've got their approximate spacing between, we'll just glue a series of 1-inch PVC lengths of pipe together. On one side we'll have the supply manifold, other side the flush manifold, and then we'll just cut in the connection tees where need be. So there doesn't need to be any measuring, we just cut and glue. Occasionally we'll be on a site where the Oscar will be on a curve. In that case, we may want to put both manifolds on the outer edge, so we have a larger radius of turn on these pipes. The only concern will be that we want to take some care that there will be one length of tubing that will cross one of the manifolds. We just want to bed that so that we don't kink that tubing. The only material that's required to cover the coils is C33 sand. You may choose to use a little bit of cover soil over the top of the Oscars, which is fine. We want to reduce that or keep that to a small layer of 2 to 3 inches. Make sure that the soil has very low organics, less than 10% usually. In cases where it may be a while before the system is going to be used, we'll want to put some straw over the top. But we want to plant grass seed or some kind of ground cover on there as soon as we can. Some people may choose to put some jute mat down to hold the sand in place until vegetation grows. Whatever we do not want to put the commercial grade topsoil mixes on there. They have very heavy organic contents, lots of compost. That material tends to hold water, and it makes the system appear to be failing when it's not. Once the Oscar is covered, it has a kind of a stark gray sand cover on top. Again, once we get things planted, it grows quite readily once the system's put into operation. Takes about 2 hours, a little less, for 2 guys to install an Oscar start to finish. That is the drain field portion. So it's a very quick and easy install. Now, the treatment vessel that we've described, it really has to meet 3 criteria. One, it must be on the Washington State Department of Health's list of registered wastewater containment vessels. The other thing must be on the Low Ridges list, which we maintain on our website. And the third criteria is these wastewater treatment vessels must have gone through an NSF test and meet at least 100 CBOD and 75 TSS milligrams per liter. Typically, any system that has done that meets a much higher standard, so we end up really meeting more like a 15-15 standard more than anything else. Thing though is, if the treatment vessel meets treatment level B, the Oscar 2 can be installed in as little as 12 inches of soil. The example would be a new water BNR 500 tank. It meets the treatment level B standards. When you use that treatment device with the Oscar 2, you'll need to order a NuWater O. It's a NuWater, it stands for a NuWater Oscar. It is the same package as the B&R 500, it's just minus the control panel. We'll be using the control panel that's included in the Oscar 2 kit. Float settings in our pump chamber. There are two floats. We want to have the bottom float at least to the top, if not higher, than the pump. The top float is about 4 inches above the bottom float. Very simple settings. The floats in the kit come with float brackets or float collars. Just a matter of tightening the stainless steel screw on the desired location. We also supply an orifice shield with the stainless screw so that we can use that to hold up our float tree. So we can just take that float tree, snap it in place. The float tree is the entire length from the bottom of the tank up into the riser. So the orifice shield is just there to hold the pipe in place. The float tree itself holds its own weight by resting on the bottom of the tank. The next item that we would need to install would be the reverse flush headworks. In our kit, we will have a flow meter, the reverse flush headworks, the pump, and a union here for installation. We also put in a 4x1 T that allows us for our flush water to enter back in the tank so that we don't have to put any more grommets in and drill any more holes in the risers to have to try to seal those. Now our headworks that we use, the reverse flush headworks, and the kit it comes with has really two options. You could use the cold weather application or non-cold weather application. Everything on the west side of the Cascades, we recommend using the non-cold weather application. East of the Cascades, please do use the cold weather application. The basic headworks comes in the package, looks like this. We have 5 solenoid valves, 3 gauges, and 1 disc filter. Also in the kit are there's the cold weather adapter as well as the non-cold weather adapter. So what will happen, the cold weather adapter is a series of fittings that allows us to incorporate what we call a keg fitting. When the pressure inside the system drops after the system is dosed, it allows about half of the water in the headworks to drain out between cycles. That would preclude it from freezing if someone were to turn the power off during the winter, say on a vacation home, and will avoid any freeze damage during the winter time. To use the non-cold weather application, we would put our plug into this T here. The kit includes what we call tail pieces. There's 5 of them altogether. They're labeled A, B, C, and the 4th one is D. If we were to use the 5th one, the cold weather application, it would go in this location here. In any event, we're going to glue A, B, and C on this side, plus the cap. And then we supply a headworks box that's already pre-drilled. We would go ahead and fish or feed the tail pieces through the 3 holes, and then attach the 4th pump line. Put the bottom, which comes with the kit, on the bottom of this headworks box. And when we turn it over, we'll have instructions on the tail pieces sticking out of the headworks of where the plumbing is to be connected to. 2 coil from coil would go up to the Oscars. And the 2 tank, this is where all the flush water would then enter back into the discharge tank. Now, if we're going to do the cold weather with the reverse flush, process is basically identical. We're going to glue A, B, and C. What we'll do different is we will put our cold weather adapter here, and we'll put the second B unit in here, or B tail piece, and you'll see it's marked 2 tank as well. Again, we turn it over, put it in the pre-drilled box, connect in our from pump line, turn it over, and again we've got the instructions on the tail pieces again. What we do recommend is cutting a couple pieces of 1-inch pipe, placing it under the headworks to give us a little space between the bottom of the headworks box and the top of the tank. You may want to put some soil around these pipes to keep them from rolling around on top of the tank until you get the system glued in place. And then we also provide you a couple street L's with a corresponding T and elbow that allows us to tie these two tank connections together. And we do want it to be able to drain, so we want to have a drop or an elevation difference. And then we lay this pipe right along the tank, and it will then feed around to our flush tee. Now, we may have a situation where we're putting taller risers on the tanks than 12 inches. In this case, we have 18 inches risers on this tank. So what we recommend is cutting an extra 6-inch piece. Basically, anything above 12 inches, we want to cut that remainder off, or in addition to. Place it on the tank where we want the headworks. Fill that riser full of soil, crushed rock, pea gravel, sand, whatever you have on site. And what that now becomes is a solid anchor, and then we will screw that headworks box to that extra riser, and now that headworks won't move. In circumstances where we may even have a 2-foot tall riser, this is what the installation would look like. Again, we're laying that flush line right along the top of the tank, and it'll go around to our flush tee on the inlet of the pump chamber. The control panel that we use in the Oscar II package is an LF1P RF BLWR. It's basically a one pump control panel with a reverse flush capability, and it'll also run a blower. You can see we've got a circuit breaker in here. It's a 10 amp breaker that will run the blower for a new water or another treatment technology as well. We also have a pressure switch inside for our blower failure alarm. And we want to see that panel mounted on a post off the wall of the house about eye to chest level. This is probably one of the more ideal installations of a control panel. Now, once the system is installed and wired, we want to conduct a quality control check called the startup procedures. In this process, we are going to verify that the floats, pumps, and valves are all wired correctly, and we'll also record the flows and pressures to be able to validate that the system actually was installed as intended. Our Headworks has a 3/4 inch filter, 120 mesh disc filter. It has 5 normally closed solenoid valves and 3 pressure gauges. The solenoid valves are made for a sewage type application. They are not irrigation valves put in the wrong application. All the valves are normally closed, which means in order for anything to flow through the valves, we need to have at least 24 volts to energize the solenoids, as well as 15 psi, or excuse me, yes, 15 psi to open the valves. So we need electrical current and hydraulic pressure. The solenoid valves are labeled S1 through S5. Our gauges are labeled 1, 2, and 3, representing the flow or the pressure on the inlet side of the disc filter. Number 2 is on the downflow side of the disc filter, and 3 is always after all of the tubing. So we can measure at all critical points within the system what the pressure is. Again, this is our basic layout of where the system is when we've installed it. When the control panel is actually set up to give us 90 doses, at the 91st dose, it's going to back flush the disc filter. After that, we are going to forward flush the coils. and then we'll start another 90 doses, and it just keeps repeating these same processes. So we want to be able to validate or check that the wiring was put together so that these functions will take place. In our control panel, you'll notice there are four toggle switches. One toggle switch will operate our pump. It can either be an auto, off, or manual, or hand. We have 5 solenoids, but two of the solenoids, 1 and 2, always operate together. Another 2 solenoids, 3 and 4, operate together, so there's one toggle switch for it. And then we've got a 5th valve, so we have a separate toggle switch for it. So if we want to test the headworks and make sure the pump is wired correctly, we will turn the pump uh, number 1 to hand, and then we also want to turn or get power to the valves 1 and 2, so we'll put the second toggle switch into the hand position. And what will happen is as the pump comes on, this green line demonstrates the flow path. Because only valves solenoids 1 and 2 are open and 3, 4, and 5 are closed, our flow path will follow this route, go through the disc filter in the forward motion, and go out to the coils in the Oscar, and then we'll deadhead against valve 5. When we do that, our pressures on gauges 1 and 2, and actually on all 3 gauges, will be about 50 psi, somewhere between about 48 and 52. And that'll indicate that we at least these 2 valves and the pump have been wired correctly. And this is what the flow path would look like if you could see how it was going in the piping itself. Once we've verified that we've got the dose works with the valves 1 and 2, we want to test the reverse flush sequence. The normal flow through the filter is water will come in the filter housing and then move from the outside of the discs to the inside center and then out to the coils. What we'll do on this filter flush is we're going to reverse the flush, make it go backwards so that it pressurizes the inside of these discs and then forces water at high pressure and flow out to remove any debris that's trapped inside the discs. What's not shown here is a spring that when the pump comes on will actually compress the spring and relax the tension on these discs, which will allow more material to be dislodged during the backflush sequence. So in our control panel, we'll turn pump 1 on. We'll turn valves 3 and 4 to hand. And then now the flow path follows the yellow line. And what we'll be able to identify a correct wiring or operation is that gauge 2 will be at about 20 psi. Gauge 1 will be at about 10. And we will have a significant flow going back into the inlet of our pump chamber. And this is what the flow path would look like. Because we have no flow and pressure going to gauge 3, it'll read 0. And if we were to measure the flow in our flow meter, we would see about 28 gallons a minute in this short circuit between the pump and back into the tank. The last thing we want to check electrically will be the flush cycle. Here we want to turn pump 1 on. We're going to have valves 1 and 2 and 5 energized. And it'll be very similar to our dose sequence, except that with valve 5 being open, we're going to relieve all this excess pressure and allow the excess flow to go back in the tank. And in this case, we're going to have pressures on gauges 1 and 2 of about 40 psi. Gauge 3 will have 0, maybe 1, 2 psi at the most. And this is what the flow path would look like in that case. Now the flow coming in the tank now will be about half of the flow as when we backflush the disc filter. We've got quite a bit of friction loss, and we do have some pressure and flow loss within the coils themselves. Now, when we're doing the dose, where we just have valves 1 and 2 open and with the pump running, we're going to want to be able to measure what the emitter discharge rate is. On these disc filters, excuse me, on these flow meters, you'll notice that we've got 3 dials and kind of an odometer here. The first dial on the right here is each digit here will represent 1 gallon of flow. On this middle dial, it's 0.1, so each digit is 1/10 of a gallon of flow. And this is 0.01, so this dial will be 1/100th of a gallon of flow per digit. So if we were to read this dial, or this pressure flow meter, this first backlit or dark background number is actually the 100s, and this is for the 3/4 inch filter. So this first number would be 200. The second number is 20. And we paint the single digit has a representation of just 0 here on the face. So we'd have to read the single digit dial, and it's less than 1. So we'd have to continue on and look at what the tenths and 100ths dial say. So if we were to record what this meter's told what their total flow has been so far, we would write 220.64 gallons. Excuse me. Now, the advantage of using this particular meter for just measuring the flow is we don't have to use any math. All we'll need is a stopwatch on our smartphone, and we'll time 1 minute, and in that minute we'll just count the rotations of this middle dial, and that number of rotations in a minute tells us what our gallons per minute flow is. Again, no math. You don't have to worry about rounding numbers, getting the right start and stop readings, and doing the subtraction correct. Just run the stopwatch for a minute and count those rotations on that middle dial. Now, the math you will need to do is you will need to have an idea of what the flow per coil is. On the 5-foot coils, or the OS50s, it's 0.35 gallons a minute per coil. So an example would be having 10 coils for a 500 gallon a day system. We would have a flow emitter discharge rate of about 3.5 gallons a minute. The OS100s are twice as large, or have twice as many emitters, so they'll flow at twice the rate at 0.7 gallons per minute. And of course, we need to know what to record. Really, it's only two criteria. We want the pressures during the dose on gauges 1, 2, and 3. And then we're going to know what the emitter discharge rate is during the dose. Now, the control panel is set up with a factory default setting of 3 minutes 38 seconds off and 22 seconds on. That does not need to be changed. The number of coils will increase the flow, but the time sequences will stay the same. These are pressure compensating emitters, so it makes it very easy to do the setup on the system, very easy to do the design as well as the installation. Now, our certification process starts with a classroom training or this online video training. Once you've completed this, I would suggest that you give us a call. We will then answer any questions you have, talk about a couple of details that we may need to go over. But from here, we'll put your name on our certified list of professionals as an installer. Then what we'll do is whether one of our distributors or someone from Low Ridge will come out and do the first install with you on site. What we would ask is that the tanks be in the ground and that you do the basal prep and place the sand on the prepared area. And then we'll help with show you how to do the coils, the reverse flush head works, and so forth. Takes really a very short period of time. Once the system has been electrically completed, we'll come out and do the startup procedures, again, to make sure that everything's working the way it's supposed to. And then if there's anything else that's needed, whether that day or in the future, whether it's a phone call, another site visit, we could even do things through FaceTime on smartphones, or pictures and text videos will work as well. So we're here to back you up, make sure you have all the information that you need. Hope this information was value, and look forward to seeing some of your installations. Thanks for watching.